Let's talk about trig identities. Trig identities are the way of taking trig functions and rewriting them in terms of other trig functions. Okay, a couple of things that we already understand. We already understand the reciprocal identities. That's sines 1 over cosecant, cosecant 1 over secant, tangent 1 over cotangent, and so forth. The new ones, the quotient identities. Remember that the tangent function is y over x, but for a unit circle, y is sine, and for a unit circle, x is cosine. Therefore, we have this, that tangent of theta, or tangent of x, is equal to sine over cosine. Well, if tangent sine over cosine, then cotangent is the reciprocal, or flip, of the tangent. So if tangent sine over cosine, then cotangent's the flip, cosine over sine. A couple of our Pythagorean identities is that sine squared plus cosine squared equals 1. Another one, 1 plus tangent squared equals secant squared. Another Pythagorean identity is 1 plus cotangent squared equals cosecant squared. All I've done down here is, for example, let's say I want to take sine squared plus cosine squared equals 1, and I want to solve it for sine squared. If I want to solve for sine squared, that means cosine squared has to be moved over. That means it becomes negative, so 1 minus cosine squared. If, however, I'd like to take this equation and solve for cosine squared, that means the sine squared has to be moved over, so that I get cosine squared equals 1 minus sine squared. I did the same ideas for the second and third Pythagorean identities written right here. Evens and odds, we understand these. Cosine and its reciprocal secant are the only even functions. Everything else is odd. Okay. These are the guidelines for how we verify trig functions. A couple of things that we're going to do is we're going to write more complicated signs in terms of sines and cosines. Basically, if you can break the function into sines and cosines, then you can work with it much more easily. Next, factor out the greatest common factor if there is one. Also, maybe you have to take a single term quotient and break it into two, either with plus or subtraction. Next, you might have to take fractional expressions using the least common denominator, and you might have to multiply the numerator and denominator by a binomial factor. Don't ever be afraid to start over again if you're not getting anywhere, because a lot of things with trig function identities is that you could go in a circle very easily. And when you find yourself going in a circle, stop, throw that away, and start again. Let's look at a couple of examples. We want to simplify the expression. So we have cosine secant minus cosine, okay? Now I like to use thetas instead of x's. It doesn't matter though, we're still using the variable. Okay, so basically whenever you have a value on the outside of a parenthesis, you can distribute through. So here I have cosine times secant. Here I have minus cosine times cosine. Oh, okay. Well, what's cosine times cosine? Oh, that's cosine squared. Well, what's secant? Secant, go back and look at your rules, it's 1 over cosine. Well, what happens here? Oh, well, the cosine and the cosine will cancel because this can be made to be a fraction over 1. Fractions cancel top and bottom. So that means that this piece becomes a 1 minus cosine squared. Oh, well, wait a minute. One trick, I should say, is that if you ever see a 1, possibilities is that it's special. And what you want to do is you want to look at your properties, your rules, your identities, and see if you can find it. 1 minus cosine squared. Let's go to our rules. Do I see 1 minus cosine squared? I sure do. 1 minus cosine squared is sine squared. Oops. And there we've simplified the expression. Next we want to verify the identity. Verify the identity means that they're going to give you a left-hand side and they're going to give you an equal the right-hand side. You want to take one of the sides. I like to use the one that's more complicated, okay? You want to take one side and you want to break it and break it and break it until it looks like the other side. So here we're going to take secant minus sine times tangent. Again, the easiest thing to start with is to break it into sines and cosines. Well, I know that secant is 1 over cosine. Bring your subtraction down, there's sine. Well, I know tangent is sine over cosine. Again, where am I getting these values from? I'm getting them from my identities, right here. I know that secant is 1 over cosine, and I know tangent is sine over cosine. Oh, okay. Well, let's look at this. That means I have 1 over cosine theta minus, this is a fraction. Fractions multiply top times top and bottom times bottom. So I have sine squared on top. Sine times sine, 1 times cosine. Oh, well, what do I have now? Now I have common denominator. Oh, okay. Well, I'm going to put this over the same denominator then, to make it one big fraction. Oh, wait a minute, there's a 1. 1s are probably special. Let me go look. Here are our rules again. I'm looking for 1 minus sine squared. Oh, there it is. 1 minus sine squared is cosecant squared. Oh, okay. That means I've got cosecant squared on top over cosine. Oh, I'm sorry, I meant to say cosine squared. Cosine squared on top over cosine. Oh, but wait a minute. Fractions cancel top and bottom, which means that one of these cancels with that, which means that I'm just left with cosine theta. And isn't this what they said to verify? Yes, so we've solved the problem. Let's do another one. Here again is a verify. They give you a left-hand side and a right-hand side. I like to start with the side that's more, I guess gives me more options, I should say. It's usually the left-hand side that it's going to be on. So here I'm starting with cotangent squared plus cosine squared plus sine squared equals cosecant squared. Alright, well, one thing to remember is that the very popular trig identity is this one right here. Sine squared plus cosine squared is equal to 1. Well, I have sine squared plus cosine squared. This is to be 1. Bring in plus. Here's your cotangent. So I have cotangent squared plus 1. Oh, wait a minute. There's a 1. That means it might be special. Let me go see. So I'm looking for cotangent squared plus 1. Let's see if we see it. Cotangent squared plus 1. Cotangent squared plus 1, there it is equal to cosecant squared. Oh, well, this is nice, because this is actually what I was told to verify. Next, I want to verify the identity. Tangent squared, sine squared equals tangent squared, sine squared. So again, I'm going to work with the left-hand side. Tangent squared minus sine squared. Well, tangent squared I can break into sine squared over cosine squared, because tangent's sine over cosine. If you have it squared, well, just square the top and square the bottom. Minus, there's my sine squared. Notice that I have a fraction here and a value here. What I want to do is I want to make it into one big fraction, which means that I need a common denominator. The common denominator between 1 and cosine squared is cosine squared, which means I need to multiply top and bottom by cosine squared. That will get me sine squared, cosine squared over cosine squared. Well, that's nice. Now they have a common denominator. Let's put them over that denominator. So now we have one big fraction. Oh, okay. Well, let's look at this. Looking at the numerator values, I think that they're sharing something. Yes, this one has sine squared and this one has sine squared. So let's pull sine squared out. The first term, if I pull that out, that leaves me with a 1. Bring your subtraction over. If I pull it out of the second, that leaves me a cosine squared. Divided by cosine squared. Oh, well, okay. Well, let's see. Well, there's a 1. There's a 1 here. What is 1? 1 is special. So let's go see. A 1 minus cosine squared. I'm going to zoom in on these so you can see them just a little bit better. 1 minus cosine squared. Oh, there it is. 1 minus cosine squared is sine squared. Oh, okay. So that means that 1 minus cosine squared is sine squared. Well, I have sine squared, cosine squared. But wait a minute. Sine squared over cosine squared will give me tangent squared with a sine squared left, which is exactly what we were wanting. Okay. Next, we want to verify the identity. Again, what we're going to do is we're going to break things into their sines and cosines. So I have sine theta over cosecant plus cosine over secant. What I want to do is I want to verify that this is 1. First thing I'm going to do is I'm going to break things into their sines and cosines. For example, cosecant is 1 over sine. Plus secant is 1 over cosine. Now, fraction division becomes fraction multiplication by the reciprocal of the denominator. So I have sine times sine over 1 plus cosine times cosine over 1. Oh, well, sine times sine is sine squared. Bring my plus sign down. Cosine times cosine is cosine squared. Oh, wait a minute. There's that famous identity again. Sine squared plus cosine squared equals to 1. And that's exactly what they wanted you to show. Let's do another one. Here we want to verify the identity. So we're going to start with cosine theta, 1 plus tangent squared theta over tangent. Okay, 1. Oh, there's a 1. Let's see if it's special. 1 plus tangent squared. 1 plus tangent squared. 1 plus tangent squared is secant squared. So that means I have secant squared. Okay. Well, let's see. Now, I wrote it down wrong, didn't I? That's cotangent. That's cotangent. Okay. Cotangent can be broken. Cotangent is cosine over sine. Secant is 1 over cosine, but it's secant squared, so I'm talking about 1 over cosine squared. We still have our denominator here. Well, what happens? One of these cosines cancels with this one. So I have 1 over sine over tangent. Oh, I'm sorry, 1 over sine cosine. That's right, because it's only 1 canceled here. There we go. Oh, okay. Well, fractions dividing becomes multiplication by the reciprocal. So I have 1 over sine cosine times 1 over tangent. Oh, but wait a minute. Tangent can be broken. Oh, okay. So that means I have 1 over sine cosine times 1 over. Tangent is sine over cosine. Alright. Okay, stay with me, alright? So now, what do I have? This is fraction division. 1 over sine cosine times 1 times the flip of this. Flip this gives you cosine over sine. Oh, wait a minute. Fractions cancel top and bottom. There goes my cosines. So I end up with 1 over sine squared. Well, 1 over sine squared. I might know what 1 over sine is. Let's go see. 1 over sine is cosecant. So if I have 1 over sine squared, that means I have cosecant squared. And that's exactly what they wanted us to show. Okay. Let's work a couple more. Here we've got cosine, cotangent, plus sine. We want to show that this is cosecant. Break it into sines and cosines. Cotangent is cosine over sine. Multiply the fractions. You need a common denominator to add these. The common denominator between 1 and sine is sine. So you have to multiply top and bottom by that. Well, now I have a common denominator, so I'm going to put them over one large fraction. Oh, but wait a minute. There's that popular one, cosine squared plus sine squared. What's that get you? 1. And 1 over sine is cosecant. And that's what they wanted us to show. Let's do another one. When you ever have a parenthesis times parenthesis, just go ahead and multiply it out. This is two binomials multiplied together. You're just going to FOIL them. So we've got secant squared plus secant minus secant minus 1. Positive secant and negative secant, that goes away. Secant squared minus 1. Oh, there's a 1. Might be special. Let me go check. Secant squared minus 1. Secant squared minus 1 is equal to tangent squared. Very good.